Unit 15, Part 1. Alright, welcome to the big climax of this part of the course on quantifier logic. If you think back to Unit 10, when we began this logic, we motivated the introduction of a new system of logic by looking at some arguments that we could all clearly appreciate were deductively, logically valid, that were all such that it was necessarily the case that if the premises are true, the conclusion was true, right? But that we could not formally grasp the validity of, given the resources of the sentential logic that we've been doing from units 1 to 9. So, for example, the argument, all cats are mammals, premise 1, premise 2, all mammals are vertebrates, conclusion, all cats are vertebrates, right? Using the resources of sentential logic, the symbolization of that, the formal presentation of that is P, Q, therefore R, which clearly does not capture or formally express the validity of the argument. Klenk presented that argument in Unit 10 to motivate this new system of logic. Why do we need to go beyond sentential logic? Because there are arguments like that that we can see are valid, that we can't grasp as valid using the resources of sentential logic. So we need a new logic so that we can grasp that validity. And hurrah, the big climax is here now, Unit 15, and she introduces this chapter by referring to that argument again on page 274. And at the end of this chapter, you will be able to formally grasp and formally present the validity of arguments like that. You will be introduced to 4 rules, these 4 rules up here, which I've already spoken about at length in the previous lectures because we've been working up to this point. You'll be introduced to these 4 rules, the validity of which you will be able to explain, right? You'll be able to say why these rules are truth-preserving, why the inferences that they entitle you to make preserve truth. So with that, in combination with the mode of analysis we've been using in predicate logic, also known as quantified logic, our analysis of sentences, right? So we started with singular sentences, and we broke that into propositional functions and individual propositional functions. Substitution instance was the singular sentence. X is Australian, goes to Dan is Australian. That was the new mode of analysis of sentences that was new to quantified logic, different than the way we were carving things up in sentential logic. And with quantifiers, with the use of quantifiers such that we're annexing quantifiers to propositional functions in our analysis of sentences, so that our analysis of particular English sentences, which use English quantifiers, some of these things are blah, most of these things are blah, almost all, right? Every one of these is one of those. These are English quantifiers. We, in quantifier logic, have quantifier symbols. So we have a new mode of analysis. So with that mode of analysis, with that quantifier logic mode of translation of English sentences, which gives us translations of, which allows us to grasp each of the sentences in the argument I mentioned as of a certain form. All cats are mammals for all x. If x is a cat, x is a mammal, A form. They're all 3 of the 2 premises in the conclusion are all A form in that argument. With that analysis and with these rules, you will finally, at the end of this chapter, be able to formally grasp the validity of arguments like those, right? The very ones that we began this logic, that we motivated the introduction of this logic in Unit 10 by saying we couldn't grasp them in the old logic. Now we finally can grasp them here. So that's why this is the big climax of this section of the course. All right, so following Klenk, I will begin with a preliminary statement of these 4 rules, which as I say, you've heard about a lot if you've been watching the lectures up to this point. The first 3, 4, 5 sections of videos for Unit 14, I sort of went through a proof, so you saw an application of these rules already. But let's get into them now and talk about them a bit at length. There are 4 rules, right? These are the rules that govern the they govern the moves that you can make with quantifier statements. Okay, they're the four rules. These four rules allow you to go from quantified statements to instances of that statements. I'll be explaining what instantiation is. Or they allow you to go from particular instances, these are going to be the G ones, from instances to quantifier statements. So these are rules which govern the adding or removing of quantifiers. Okay, so that the rules that allow you to do things with quantifier statements. Okay, so their names are universal instantiation, existential instantiation. These are the instantiation rules. They are the ones that allow you to go from quantifier statements to instances of those statements. They will be the ones that will be used usually at the beginning of proofs. If you're given quantifier statements, you'll be instantiating from those quantifier statements to get formulas that are instances of those statements. And then there are the generalization rules, which allow you to go from particular instances, or I could say particular singular sentences, right? With instances are going to be individual constants, like these are all FA here. The generalization rules will allow you to go from singular sentences, instances of quantified formulas, to the quantified formulas. Okay, so you've got instantiation, you've got generalization. In each case, you've got universal instantiation, existential instantiation, universal generalization, and existential generalization. Those four names kind of tell you what each one is, right? So you don't have to do a great deal of work. Oh, which one's universal generalization again? Which one's existential instantiation again? Right? If it's got existential in the title, then the rule is either coming from or going to the existential quantifier, right? Existential instantiation is going from the existential quantifier, right? It's a rule that entitles you to move from an existential statement to an instance of that statement. Again, I will speak at length about what an instance is or what instantiation is. Existential generalization is going from a singular statement to an existential statement. So existential instantiation is getting rid of the existential quantifier. Existential generalization is adding the existential quantifier, and something similar for universal instantiation and generalization. Universal instantiation is getting rid of the universal quantifier, right? Moving from a universally quantified statement. Universal generalization is moving to a universally quantified statement, right? So there's that. So you don't have to do a lot of. I'm saying you don't have to do a lot of thinking to remember what a rule allows you to do. It says what it allows you to do in its name. There are two parts to explaining that. I just went through the first. If it says, if the rule has the word universal in it, it's either coming from or going to a universal quantifier. The second part of the name of each rule is instantiation or generalization, right? So what is instantiation and what is generalization, right? Universal instantiation means you're going from the quantified statement to an instance of that statement. What is an instance? So what is a universal statement? It is a statement that says, let me back up. What is a quantified statement? A quantified statement is a statement. A quantifier statement is a statement that says of how many things the propositional function is true, right? A universal statement says that the propositional function is true of everything, okay? So universally instantiating, moving from a universal statement, is moving from the statement that says that this propositional function is true of everything to, right, you're inferring from that to this statement is true of this particular individual, of this instance, namely A or B or C, where, right, so instantiation, as Klenk tells you, you do it by deleting the quantifier and replacing the variable that is bound by the quantifier, wherever it occurs, with the same individual constant. Replacing a variable with an individual constant, the x, usually it's the x becoming an a. I should say, Klenk presents these with phi and psi instead of just f, for a good reason, namely, the phi and the psi, she explains they can be complex formulas, right? Formulas of any complexity, or propositional functions, or particularly of any complexity. I find that when I present them that way, people sort of get lost. So I'm just using f, but you have to appreciate that most of your instantiations are not going to be of a simple propositional function like this, right? Here's a sample, a more typical example of what you'll be instantiating from, right? This is the universal statement for all x. If x is f, then x is g. Using ui on this formula, right? What does this tell you? This says that everything is such that if it's f, then it's g. So it's true of the individual Andrew, it's a, f a, g a, right? That's a step in a proof. You're universally instantiating from one, okay? But what is instantiating? It's going from the universal quantifier to its truth that this propositional function is true of this individual, right? So you're instantiating, you're applying it to an individual, a named individual, right? Fa, remember when we started, right? And so fx, just that formula, that's a propositional function which consists of a predicate letter and an individual variable. Why are propositional functions not sentences themselves? Because of the presence of this variable. It doesn't assert anything true or false. It needs to be completed either with a quantifier or by having a substitution instance that is a singular sentence. It's the other way to get a propositional function. You can make it a sentence by having a singular sentence as a substitution instance, or annexing it to a quantifier to get a quantified sentence. And this itself is a propositional function, right? And we get singular sentences by, right, this is an individual variable different from a sentential variable. Remember, sentential variables took, from sentential logic, took sentences as substitution instances. Individual variables that we're working with in quantified logic take as substitution instances individual constants. Individual constants, like A or B or C, which stand for individuals. So what is instantiating? Going from this propositional function is true of everything, so to it's true of Andrew, or Bill, or Thomas, right? Some individual.